Hi, I'm Carlton Ray, Director of the Clean Rivers Project, a $2.6 billion program that captures combined or raw sewage that's currently going into the Anacostia River, Potomac, and Rock Creek every time it rains. We're building a tunnel system that will divert the flow and convey that down to Blue Plains Wastewater Treatment Plant, the world's largest advanced wastewater treatment plant.
This project is a water pollution improvement project. What we're doing here is we're excavating a tunnel 2.5 miles long and 23 feet in diameter. And then it's going to intercept sewer overflows, which are a combination of rainwater and sewer water that normally go into the river. Put those into this big pipe, which will go down to the water treatment plant.
Surface operations are a vital part of the process. Every day, up to 40 trucks with segments are delivered to the job site, together with other materials such as bentonite, cement, and other consumables. The material is then stored up in the surface and then lowered down in the tunnel and toward the tibia.
We have a lot of people who work here. We have approximately, at the peak, somewhere around 200 people working here. We have all kinds of people from all over the place. We have people from Italy working here. We have local people working on this project, labor, union, operators, and we're all working together for Washington, D.C. and for our owner, DC Water.
The muck remover from the job site is another very important part of the process. Every day about 300 trucks are coming and going from the job site, removing up to 2,500 cubic yards of material. Logistic of material coming and going, together with the muck and all the consumables, is a key part of your operation. Right now we are excavating in a very thick clay. In order to be able to transport the material properly, we need to treat the material inside the excavation chamber. We inject water, foam, and polymer, mix it with the excavated material, and then condition it to the point where it's discharged in the conveyor belt. You can see that the TBM and the conveyor belt are a combined system. It is continuously transporting the material out from the tunnel. Without the conveyor belt, you cannot do the excavation with the tibia. It's a continuous operation and it is a key component of the whole system. You can see the 50-ton gantry crane, which is transporting the material from the shaft pit all the way to the surface. The clamshell is a 16 cubic meter capacity clamshell and is capable to transport about 30-40 tons of material all the way to the surface. This is the heart of the machine. This is where all the material are received and controlled. One ring is offloaded in this area with the segment crane toward the feeder. The feeder is transporting the segment all the way to the TBM ring assembly area. One ring is built in about 25 minutes and is composed by 6 segments plus the key. There are longitudinal connecting dowels and radial bolts which are connecting the segment together. And the ring is designed for a durability of 100 years. You can also see the TBM operator in communication with the grouting operator. The grouting operator is controlling the backfill grout around the segment, and in this area can communicate directly with the TBM operator. So now we are in the operator cabin. Basically, this is the brain of the machine. You can see all the parameters of the machine. You can see the speed, you can see the penetration rate, all the hydraulic system. You can see one of the main factors on the machine, which is the EPB pressure. Right now we are excavating at about 2 to 3 inches per minute. And the push is normally taking about 30 minutes, and then in 30 minutes we are beating the ring. One of the things you can see here is also the balance of the spoil. So it's important that we excavate and we keep under control the material. And then you have all the camera for the conveyor belt at the location of the 3 boosters. The machine is on the right spot, and it's very important to complete the excavation in the right position with the machine. We have very tight tolerances in terms of horizontal and vertical, and our operator are doing a good job with this.
We are almost done with the tunnel. There's a few rings left, and try to do the best that we can do it and complete the tunnel for this project.
We have about 116 feet to complete the excavation of the tunnel, and the crew is very excited about this.
Once we finish the tunnel system, we will capture 98% of combined sewage or raw sewage that's currently going to the river on an annual basis. That's amazing capture, and today we're at the terminus of the Anacostia River Tunnel, the 12,500-foot tunnel that's part of our overall 13-mile tunnel that convey the sewage to Blue Plains. We're excited to have Cellini Impogilo and Parsons joint venture team to successfully complete the project along with DC Water and the Clean Rivers program. That partnership has allowed us to be on schedule and on budget, and we're excited for that to occur.
Washington, D.C., like many cities in the United States, has an old sewer system that often gets backed up by huge volumes of runoff whenever there is a heavy rainstorm. That is how millions of liters of untreated water and raw sewage become such a risk to public health. They become a toxic mix that flows into Rock Creek and the Potomac and Anacostia rivers. They also can cause flooding in the streets of the district. To drastically reduce the polluting of the waterways and protect local marine fauna, the District of Columbia Water and Sewer Authorities has been implementing the Clean Rivers Project. This ambitious project to protect the environment involves the expansion of the district's network of tunnels, sewers, and other facilities that runs under the District of Columbia. Once completed, the network will be better able to capture storm water and sewage and deviate it to the Blue Plains Advanced Wastewater Treatment Plant in the city's southeast. The Clean Rivers project should be completed by 2023 at a cost of about $2.7 billion. In June 2013, Cellini Impogilo, with its subsidiary Lane Construction Corporation through S.A. Healy Company, along with Parsons Group, started work on the Anacostia River Tunnel in Washington, D.C., the second of 4 tunnels which make up the Clean Rivers project. In November 2016, the first phase of the Anacostia project was completed. A tunnel boring machine called NANI, with earth pressure balance technology, finished excavating a tunnel that runs more than 12,300 feet, or 3,700 meters, from Robert F. Kennedy Stadium to the Poplar Point pumping station. The tunnel is 23 feet, 7 meters in diameter, and varies in depth from 50 to 160 feet, 15 to 48 meters. The tunnel passes under the Anacostia River, a railroad, a subway, and an interstate highway. The machine was applauded when it arrived at its destination, affirming Cellini Impogilo's pride in accomplishing a public work in the United States. The Anacostia project includes 6 shafts of various sizes, 4 diversion chambers, 3 complementary tunnels, and ventilation control systems. The Anacostia River Tunnel is one of Cellini Impogilo and Lane's biggest and most complex projects in the United States. It confirms once again the group's dedication to supporting clients in safeguarding the environment. The tunnel, connected to the district's network, contributes to reducing the volume of wastewater and runoff that flows into the waterways by 98%. It also helps reduce the probability of flooding in the Washington, D.C. area from 50% to 7%. This is a significant accomplishment that will improve the quality of life in the capital of the United States and make public health safer and put the city at the forefront in terms of environmental sustainability.